Below the surface, a once thriving, lively ecosystem is dying right in front of our eyes. Climate change and invasive species have thrown kelp ecosystems out of balance, disrupting food webs and disturbing processes that once kept populations in harmony. Rising temperatures have killed off or displaced kelp's natural predators. Without these predators, sea urchin populations are booming and the underwater forest is being eaten alive. These spiny invaders move quickly and in numbers, grazing relentlessly until nothing remains. What once was a lush, vibrant kelp forest is becoming a lifeless wasteland. Invasive species often thrive in warmer, disturbed water, meaning climate change helps them spread faster. Kelp needs cool waters, usually between 10 and 20 degrees, to grow and reproduce, so as ocean temperatures increase, their ability to reproduce and recover from damages decreases. Kelp forest decline destabilises marine food webs, alters nutrient cycling, and reduces the productivity of an entire coastal ecosystem. Across the world, from Japan to Tasmania, kelp forests have vanished. These losses ripple through the entire marine food web. Fish, abalone, and crayfish disappear. Carbon storage declines. Coastal communities lose fisheries and tourism. The death of a kelp forest is like losing a rainforest of the sea, taking with it biodiversity, shelter, and the balance that countless species depend on.
To help combat the rising pressures posed by climate change on kelp forests, there are many different strategies that we as humans can put into place to help kelp forests not only recover, but thrive. One of the best ways to help kelp forests recover is the implementation of restoration efforts. These restoration efforts can come in many different forms, with one of the more effective methods to combat climate change being the replanting and seeding of kelp in areas that have seen a decline in kelp population. The replanting of kelp can occur at many different stages of the kelp's development, which includes the embryonic stage, juvenile stage, and adult stage. At these different stages, there are both advantages and disadvantages. The later on in the development that you transplant the kelp, the more likely it is for the kelp to survive and grow. This, however, comes at a high financial cost, as it will take more time and resources to culture this more mature kelp when compared to the younger kelp. To help enhance the success and resilience of these replanted kelp, selective breeding can be used to help increase the tolerance of the kelp to the changing environment, like increased tolerance to higher pressures. This can be achieved through priming-based breeding, which involves exposing kelp to high temperatures before breeding to promote thermal resilience in offspring. Replanting and reseeding of degraded kelp forests will not only increase the number of kelp in the system, but also the resilience of the ecosystem against other stresses.
Kelp forests are the lungs of the ocean, rich, productive, and vital for marine life. While across Australia and the world, these underwater forests are under threat by invasive species. The long-spined sea urchin from New South Wales has spread out, overgrazing kelp in Tasmania. The Japanese kelp grow rapidly, outcompeting native kelp for light and space. The Asian seaweeds are also invading reefs, transforming once diverse ecosystem into bare seascape. Together, these invaders threaten fisheries, carbon storage, and coastal protection. To combat this, divers and fisheries lead many removal programs, cleaning up urchins and invasive algae to help kelp recovery. Predator restoration program reintroduce lobsters and sea stars to control urchin number naturally, while biocontrol research explores using safe native species to outcompete invaders. Meanwhile, citizen scientist initiatives allow locals to report new outbreaks early, giving scientists a vital head start. Each of those solutions shows the recovery is possible when communities, researchers, and policymakers work together.
Deep below Tasmania's coastline lies a forest few have seen. A forest made of kelp, not trees. These giant kelp forests once stretched for kilometers, sheltering fish, seahorses, and marine life of every shape and color. But now almost all of it is gone. In the past few decades, around 95% of Tasmania's kelp forests have vanished. The seas are warming, the waters are losing nutrients, and invasive sea urchins are turning rich forests into empty rock plains. But it does not have to end this way. Across Tasmania, scientists, divers, and communities are taking action, planting new kelp, removing urchins, and giving life back to the ocean. Their work proves that restoration is possible, but they cannot do it alone. This is our moment to help. Here's how you can make a difference. First, support organizations restoring Tasmania's kelp forest. Second, choose climate-friendly habits. Less waste, less carbon, and more awareness. Third, speak up for marine protection and sustainable fishing. Fourth, if you're a diver, protect the kelp you swim through. Every blade counts. Imagine swimming through a forest reborn, sunlight streaming down, fish blending between golden fronds, the sea alive once more. Together we can make that future real. Protect the kelp, protect the ocean, and protect the planet. The ocean is calling. Will you answer?